And can I ask Lawrence to introduce tonight's guest speaker, please?
Absolutely. So tonight we welcome Mr. Bill Barton. Bill left school in 1979 with O-level qualifications, a 4-year apprenticeship in signal engineering with British Rail at the time followed. After 35 years service, he took early retirement from Network Rail, as they are now known as, in 2014. He joined the British Astronomical Association in 1983 and contributed to their solar section between 1990 and 2000. He shared his observations with the solar division of the American Association of Variable Star Observers. Other favourite observing activities include eclipses, transits, and planetary conjunctions. However, history has always had a strong calling for him, and in 2002, he was a founder member of the Society for the History of Astronomy. In the same year, he was elected a Fellow of the Royal Astronomical Society 2003, saw him licensed to operate the Orwell Park Refractor, IAU Observatory number 582. On behalf of the Orwell Astronomical Society, Ipswich, which he had joined several years earlier. He has received the SHA Roger Jones Award for contributions to their County Survey of Astronomers on several occasions, and in January 2020, he was appointed as Deputy Director of the British Astronomical Association Historical Section. Bill has a particular soft spot for classic telescopes. He was telling me this evening, in fact, such as the Carl Zeiss Telementor refractor and the Q-Star. I could never pronounce that. Could you help me with that one?
What, the Questar?
Yeah, the Maxubok. I can never pronounce that.
It's a 3.5-inch aperture Maksutov Cassegrain telescope.
He owns some astronomical antiques, such as eyepieces, micrometers, planispheres, and similar teaching aids. He has more old astronomy books than he also likes to admit to. So, can we please give him an expert Swinton astronomical welcome this evening?
So, my subject this evening is why the canals on Mars never existed. I was fortunate enough to be a BAA member back in the days when Patrick Moore still went to the meetings in London. I just missed his being president. President in my day was a young lady called Heather Cooper, and I believe that I was the first person she welcomed into the BAA in her office as First Lady President of the BAA. The BAA started in 1890. One of the reasons it started was because women essentially couldn't do anything in astronomy. They weren't allowed to be fellows at the RAS, and it was very difficult for them, because of their gender, to get the job at an observatory. There were 1 or 2 exceptions. There was a lady who worked at the Cambridge University Observatory, and Christie, the astronomer royal, in the 1890s, tried to employ women at the Royal Greenwich Observatory. He took on 5 who'd come from Cambridge. They studied mathematics there. They were probably as good as the men. Some of them took the Tripos examination, fiendishly difficult examination in mathematics. Normally lasts 5 days. Sat there and grilled on mathematics for a whole week. They couldn't be awarded degrees. The university just wouldn't do that. But Christie found 1 or 2 of these women, offered them employment at the Greenwich Observatory, but he only paid them the same as the boy computers. And within about 5 years, they'd all left to go on to do other things. But I did hear this talk by Patrick Moore back in 1985. I say a very entertaining talk on how the lunar craters were formed. All the junk theories that have been proposed over the years about the moon and the craters. There was one idea that they were coral atolls, sea that existed on the moon. Another astronomer pointed out that some of them had central peaks and some didn't. This to him was clear evidence that there'd been a nuclear war on the moon, and they'd used different sorts of bombs to each side, one of which left a central peak and the other one didn't. So, story starts with this man, Schiaparelli. He was director of the Milan Observatory, and he observed Mars in 1877, a particularly good opposition of Mars. An American astronomer, Asaph Hall, discovered the two moons at that opposition. So it's the very best opposition you could probably have for many, many years. He drew a map of Mars, and he had sort of what you might call dried up riverbeds that he called canals, if you will. You've got Hellas, and that might be surface major. Now, there's clearly recognisable features of that are on Mars even today. So that was the start of it. But this chap, Percival Lowell, read this book by Camille Flammarion about the planet Mars in 1892, and he'd heard the work that Schiaparelli had done, and he jumped to entirely the wrong conclusion, that he thought canali were canals. He'd been to Harvard College, and he was from a very well established banking family. I've had one or two goes at trying to work out his personal wealth, and I've not come up with an answer yet, but he was extremely wealthy, should we say. Prior to astronomy, he was interested in China and Japan, and he travelled to those countries, and he spent a couple of years there and even wrote books on Oriental culture. But you heard that Schiaparelli's sight was failing, and he felt that somebody had to take on this work and study the planet Mars in unprecedented detail. And so from the 1890s, he gave up all his other interests, devoted himself entirely to working on the planet Mars. I do need to mention this lady, Rexy Leonard. She was officially his secretary and assistant, but it seems that she spent as much time in the observatory as he did. There are several observations of Mars with WL next to them, her initials, so that's what she observed. He clearly believed there were canals on Mars, and it seems that she did as well. Although, of course, he was paying her wages, so maybe it was, just keeping in with the boss, shall we say. He had the whole of the continental US of A to choose from. So he, another astronomer called Douglas, travelled over the whole of the US trying to find the very best observing site. And they settled on this town of Flagstaff in Arizona, an observatory which I have visited quite a few years ago now, but yes, I have been there. It is 7.5 or hosts on 7,500 feet up in the air. For somebody who comes from Suffolk, even sort of 10 feet up in the air, I'm starting to feel the thin air. I can tell you, walking around, you really did know that you were somewhere high up in the atmosphere. So from 1894, he was there. He went to perhaps the best telescope manufacturers, certainly in America, like the world, Alvan Clark. They specialise in making refractors, lens telescopes. It's been said of them that 5 times over they made the world's biggest refractor. They made a big refractor for somebody. A couple of years later, somebody else came along. Can I have a bigger one? Oh yes, we can do that. And again and again and again. And they did make the world's, even now the world's biggest refractor, the Yerkes refractor, a 40-inch aperture telescope. But Percival Lowell went with something a bit smaller, 2 feet in aperture, and it's said to have cost him $20,000.
Oh,
They were intensively studying Mars from 1893 down to 1908. There it is. I've actually stood in that dome. I wasn't there at night, so I can't actually claim to have looked through it. It's a bit unusual because the whole of the dome structure is made of wood. And yes, these are car tyres, car wheels around here. These were added after Lowell's time in an attempt to make the dome turn a bit easier. The wooden wall and the ring of the dome, change shape with temperature and humidity, and there was an attempt at one point to make the dome turn a bit easier. That they put a second wall around the inside of the observatory, and they filled it with brine, and then they attached wooden floats to the inside of the dome to try and push it up. They chose brine rather than water because they thought it would have a lower freezing point, would be able to withstand the low temperatures that you get up the bottom. But they were wrong. Brine you can see how fabulously wealthy Lowell was, in that he was able to employ several astronomers. Unfortunately, even quite early on, Lowell Observatory got painted with this idea of Martian Canals. Some could always see them at Flagstaff. Some other astronomers could see them, but a great many couldn't. Even in Lowell's own time, people were making suggestions of why the canals were there. In this country, Edward Maunder, who was prime mover behind the BAA at the time, he got some schoolboys out of the school in Greenwich and drew circles on bits of paper and put dots on them and held them at distances away from the schoolboys. He felt that schoolboys would have no knowledge of what they were supposed to be doing. And when he asked them to draw what they saw, was they started drawing lines, because the dots just know what the human eye will resolve. Brain fills in what the eye can't do, kind of thing. So it is Mr. Douglas, who was Lowell. Unfortunately, he made a comment one day. He felt Percival Lowell wasn't a man of science and never would be. The result was he got sacked. But he went off and he got very interested in solar studies, looking at the sun. He worked out that the sun has kind of cycles of activity, and he founded the science of dendritic phenology. The idea that 3 rings match the same pattern of activities you see on the sun. You start from what we know of recently dead tree, and you can work back and back and back by over there in different records. There were the Cipher brothers, and Vesto Cipher gets his name in the history book because he's the first chap who actually measured redshifts in galaxies, which is kind of the start of work which was completed by Edwin Hubble. The idea is that the further a galaxy, or further away a galaxy is, the greater its redshift is. So the expansion of the universe is a real thing. But later at the Lowell Observatory was Clyde Tombaugh, who went on to discover the planet Pluto. Maybe that's a whole other evening's presentation, but he was an amateur astronomer who sent observations in to the Lowell Observatory, and they liked them so much they said, "We can come and work here." That point in history, this is sort of the 1920s, Lowell Observatory didn't have particularly much money. They said, "Well, we can't really pay you that much, but if you really want to come." And he set about trying to find a planet beyond Neptune, which was another one of Percival Lowell's kind of hobby horses. They rubbished all the previous attempts, and I think they spent about a year just thinking about what they were going to do, what would be the best chance they could get to discover the planet. They did it photographically. Maybe I should have included an image of the telescope they used. It's a very rough and ready thing, but it was designed not to look through, just to take photographs of the night sky. And not long after they started searching, Tombaugh had two images in front of him, and on one there was a dot, and on the other image the dot had moved by the amount he knew it would have to move to be a planet beyond Neptune. He must be kind of unique in world history that he could see this not at the telescope but in the lab. His boss, one of the Cipher brothers, was working in office a few doors down, and he had to walk down the length of the corridor, being the only person in the world those few moments who knew about the planet Pluto. Another later employee was Robert Burnham, and people like me, Burnham's Celestial Handbook back in the day was the go-to. You might start in astronomy using Norton's, but then you would move on to maybe a better set of star maps, and Burnham's Celestial Handbook would answer any question you had about a particular star or galaxy or a deep sky object. I thought I'd put up a slide of how Mars and the Earth compare. Now, of course, we're very familiar with the Earth, we live on it, but how similar is the planet Mars? Well, of course, the day length is very similar, 24 hours on the Earth, 24 and a bit hours on Mars. Sorry, that's the wrong number. That should be 25. Axial tilt is again very similar. We have 365 days a year. There's over 600 days a year on Mars, so that it's starting to show some difference. We're 1 AU away from the Sun. The planet Mars is 1.5, because that may not sound too much difference. But in astronomy, we have a thing called the inverse square law. Two objects of the same brightness would appear to be the same distance. If you double the distance of one object, it doesn't appear as half as bright, it appears a quarter as bright. So not 1/2, 1/2 squared. 1/1.5 squared is over 2. That is to say that Mars receives light and indeed heat from the Sun. It only receives less than half that we do. The surface gravity is also considerably weaker. This is our eccentricity. So that's a pure number, and it describes how the Earth's orbit is not circular, but tending towards an ellipse. Back in the day when I was a solar observer, the Earth-Sun distance varies slightly through the year. I had to slightly adjust my telescope, summer and winter, because the projected image would be a slightly different size. It might surprise you to know that we're at the closest to the Sun in December, January, the furthest away in the summer. Temperature we feel has got more to do with the angle of the Sun. But as you can see, we're 0.01, that's 0.09. Mars's orbit is decidedly more elliptical. So when it's closer to the Sun, and further away, they're very real effects on the planet. One of the other problems in observing the planet Mars is you get periods of frenetic activity followed by virtually nothing. It comes to opposition at just over 2 yearly intervals. And so these are the oppositions around the time that it was being studied at the Lowell Observatory, starting off with the one in 1877, with particularly good opposition. Here's a slide that's showing the difference between a really good opposition, a rather poor opposition, and then when Mars is on the opposite side of the Earth. So as you can see, that's an object you can study. This one perhaps it's very much smaller. This one is so small you can't see any detail. Literally can't do anything. So you have a period when you're observing the planet intensively as possible, and then as it moves away from opposition, starts getting a bit smaller, you get to the point where you have to give up, and then you're in a vacuum for the best part of 2 years. And of course, because the rotation period of Mars is only slightly greater than the Earth, if you go out and look at it at the same time every night, you see more at the same time. You have to keep going for about a month before you actually see the whole of the planet. So again, it's maybe not the easiest of objects to observe. But this is what they thought they were looking at. Absolute mass of lines, and the more that they looked, the more lines they could see, or they thought they could see. Very strange, really, because you're looking at what you think is a natural object, and you've got these straight lines, which you don't get straight lines in nature. So clearly, Lowell thought that these had to be non-natural, I think was the point the words he used at one point. Here's a later map of Mars, when maybe some of the canals had fallen out of favour a bit, but they're still trying to draw the lines in there. So, for the canals to exist, Lowell thought there had to be an atmosphere capable of supporting life, that is, as oxygen, and clearly the canals were there to transport water, so there had to be water on the planet. And Lowell said, well, I know that both of these things exist because I've detected them with my telescopes. That is to say that he attached the spectroscope to the back of the telescope, and both oxygen and water produce a characteristic set of lines. But of course, he's doing it from ground level. You're looking through an atmosphere which contains oxygen and water vapour. How he convinced himself that these chemicals existed on the planet, even if you look at a blank piece of space, you will pick up the water and oxygen lines. He also made all sorts of, what to me seemed quite ridiculous claims. He said, well, there's been no ice ages on Mars. there are no mountains on Mars. If there are no mountains, then you can drive a canal clear across the countryside. How he, you know, it just doesn't sort of stand up that you have a completely smooth planet. If Mars was supposed to be so like the Earth, and yet clearly the Earth, the planet, has mountains. Looking at what you get in atmospheres, nitrogen, oxygen, carbon dioxide, and water vapor. Nitrogen and oxygen don't like being singular atoms. They like being a molecule. If they can't find anything else to join with, they find another atom of themselves and join with that. So you get N2 and O2. So although the molecular weight of a nitrogen atom is 14, the mass of a nitrogen molecule is 28 because the 214. And again, oxygen is 16, so you get 32. But hydrogen is the lightest of all elements. And so water vapor, being 1 oxygen and 2 hydrogen, is only 18.01. It's only very slightly greater than a single oxygen atom. On the other hand, carbon dioxide is O2 plus carbon. So you can draw up the table and say, well, carbon is the heaviest, water vapor, oxygen, nitrogen, water vapor is the lightest. Going back to the previous side of the table, comparing Earth and Mars, I said that the surface gravity of Mars was very much less than Earth. Clearly, there is no hydrogen or helium in the Earth's atmosphere. They're too light for the Earth's gravity to hold on to. A helium balloon will rise through the atmosphere to the point where the helium gas escapes into space. So it seems unlikely to me, given the smaller size of Mars, that the planet would have been able to hold on to water vapor. It can certainly hold on to carbon dioxide. As we know now, the Martian atmosphere is virtually all carbon dioxide. As I said before, the more they looked, the more they saw. They came up with this word gemination, in that when they saw a canal, they often saw a second one running exactly parallel with it. Again, I've got kind of no explanations as to why that should have been on the planet, but there we are. And they also had these oases, which were dots, where the canals join. The idea in Lowell's mind was that it kind of never rained on the planet. There were people on the planet who were desperate for water, and they were tapping the polar caps. That was his idea, so that as the polar cap at either northern or southern end of the planet shrank, the water was going into these canals and being transported down to the equatorial regions. This is where my training as an electrical engineer comes in, because where he had water, I see electricity, and it's kind of like an electrical distribution system, my mind. So that, you know, when you get canals joining, you can't have more water flowing away from the join than flowing towards it. You can't invent electricity or water at any particular point. So if you did have canals feeding water down from the polar region and the junction, when it carries on, it's got to have the same amount of water. So, you know, why is this line up here thinner than that line down there, kind of thing? So as I've said, Mars' gravity is weaker than the Earth, so the atmosphere had to be thinner, and it probably wasn't strong enough to hold on to water vapor. It's because it's smaller diameter, it's a smaller volume. And again, Lowell was arguing that it had less internal heat. But what we now know is that that is actually a spurious argument, because the internal heat in the planet is essentially locked inside the soil, and rock is actually quite a poor conductor of heat, and the heat deep inside the planet cannot leak out through the surface. As I've already spoken about the solar heating, so Mars only receives something like 44% of what we get here on Earth. So maybe it was never warm enough for there to be liquid water on the surface. And I've already talked about the atomic weight of the atmosphere. So, as I've already said, there were long periods when Mars couldn't be observed, and they were just sat there looking at each other and thinking, what can we talk about next? There were good oppositions, and there were poor oppositions. The 1877 one was particularly good. And then as you went on through time, they got consistently poor after several years. And so they were kind of batting what you might call a sticky wicket. Every opposition that came round was slightly worse than the one before, and it was slightly smaller, not so much detail to be seen. And indeed, these canals only seem to be seen at second grade positions. For some reason, Lowell wanted the canals to extend beyond the equator. Well, if you've got two polar caps feeding water down, why does the water need to pass the equator? He said that the blue tint on the surface of Mars was where you saw water. Well, as we now know, the sky on Mars is a pink colour, not a blue colour. The water is blue because it's reflecting the blue sky. Mars orbits outside that of the Earth. Mercury and Venus that are inside the Earth's orbit, when they're between us and the Sun, you're looking at the night side of the planet. And when they're on the far side of the Sun, you're looking at the day side of the planet. But planets outside the Earth's orbit, you only ever get to see the day side. Whether they're on this side of the Sun or the far side. And in the case of Mars, at opposition, this figure would be 1. As you move away from opposition, it drops down a bit. You can just see very slightly the night side, but you can never see what you might call the true night side. So astronomers were never able to say, well, there's no artificial lights on the planet. You just can't see far enough around. But Lowell would have said, oh, well, they don't have electricity, or, you know, he'd have thought of some reason for why that wasn't the case. But if you've got surface water, you've got the Sun behind you, you've got Mars in front of you, you should at some point see the reflection of the sunlight in the water. And that was never seen. At one point that Lowell said, well, the lines that we draw aren't actually the canals, they're kind of the, what you might call the infrastructure around the canal. You may have even argued that the canals have actually been roofed over to prevent evaporation. And you never saw a flash of light from what we would say here on Earth would be a thunderstorm. You always just saw the planet. So an indication maybe that there's no actual weather on the planet. At the time Lowell was working, yes, photography was coming in, but a lot of astronomers just used to stare down the eyepiece of a telescope. Even on good nights of good seeing, you get periods of turbulence, and then you get a clear patch. And so astronomers would stare down the eyepiece of a telescope, waiting for those few moments when what you're looking at comes into absolute clarity. And then, of course, you remember what you saw and drew it. But of course, all the while you're sitting there staring down the eyepiece of the telescope, the eye and the brain are getting fatigued. Yes, Lowell heard of canali, and he built canals. There was a lot of problems of translation between languages. Different observers saw different canals. Well, if they're real, then you should all surely be seeing the same sort of thing. And this is another one that didn't follow the law perspective. As the planet turned, you didn't see them square on and then see them more and more foreshortened. And indeed, many astronomers either didn't see them or came up with alternative explanations. And I'll just put the note in the bottom there, Kirchhoff's laws, which is what I was saying earlier about instead of talking about water, we talk about electricity. The way electricity flows around the Turk is kind of very similar to what Lowell was saying that the water did on his canals. There's all these words, most of which I can't pronounce. And they were all to do with the eye and brain combination. Human head, you're seeing things that aren't really there. If you're shown random dots, you try and draw a pattern. Mars is predominantly red in colour. If you stare at a red object for too long, if you look away, you get an after image of green. And of course, Lowell wanted to see green because that was the colour of vegetation, and he was determined that the canals were feeding vegetation. Lowell was, as I said earlier, a poor scientist. He had an idea in his head, and then he looked at the evidence to back that up. He had a 24-inch aperture telescope. He decided in the early years of the 20th century, rather arrogantly, that he discovered everything that there was to discover on Mars, and he moved on to the planet Venus. He just observed Venus by daylight, and again, that's one of the things that I really like doing as well. Being able to find Venus is one thing in daytime sky, but when you can actually see the planet, I feel you can see certainly Venus, and to an extent Mercury, better at during the day, simply because they're at much greater altitude than early in the morning or late in the evening. And then there's this thing that he called Flagstaff seeing. He felt he had the best observing site in America, probably the whole world. He claimed that this meant that he could see the canals on Mars. He could draw them. There were one or two photographs that he claimed also showed them, but when they tried to reproduce the photographs so that they could be put into books and magazines, lo and behold, the image of the canals was so faint it wouldn't reproduce. So if you wanted to go and if you wanted to see the canals, you had to go to Flagstaff to see them. And of course, in his day, dry ice wasn't a particularly familiar substance. I've got a record of it being commercially available only in the 1920s. And so when you saw a planet and you saw a white polar cap, you just assumed it was water ice. The fact that it's actually solid CO2 couldn't really come into the argument at that point, because say they weren't familiar with dry ice. He overestimated the temperature, the atmospheric pressure, and indeed the presence of oxygen. You know, he was really kind of, this is what it is, this, just to make the canals actually work. He wrote 4 books, 3 of which are mostly about Mars, and then a more sort of general work, which comes somewhat later. So in each one, he was building the argument more and more and more as to why there were canals on Mars. So he starts off with a book about Mars, then he's writing about the canals, and then he's writing about life on Mars. In the UK, there was a chap called Alfred Russel Wallace, who wrote this book, Is Mars Habitable? it's about half the size of Lowell's, and he absolutely destroys Lowell's argument every time that there literally cannot be any life, therefore there are no. Said a moment or two ago that Lowell moved from observing Mars to observing Venus. He observed in daylight using the 24-inch refractor, stopped down to 4 inches. Why would you do that? You could just use a 4-inch refractor, surely. This is what he saw on the planet Venus. Both he and Rexy Leonard drew very similar ones. Although he later he did actually publish a retraction and said no, we didn't actually see that. But there's a kind of a hint here, because for many years now it's been known that when you look at the planet Venus, you're looking at the top of an opaque layer of cloud. So when it's away from full phase and you're looking at partial phase on Venus, you can see a hard edge, and then where the shadow edge is distinctly softer. It's very clear that you are looking not at a solid object, but at clouds. And so it's been suggested by Bill Sheehan and Thomas Dobbins that because he was using a very big telescope, stopped down to a very small amount, the size of the bundle of light rays coming out the eyepiece was extremely small. So these days, if you ask an astronomer what the magnification of the telescope is, they kind of look at the front end and see what the focal length of the main mirror or lens is, because they normally write it around the circumference. And the focal length is stamped on the eyepiece, so you divide one by the other. But there is another way of doing it, using this one. So the entrance pupil is the diameter of the main lens or mirror. Well, that's relatively easy to do. You just get a tape measure out and measure across the diameter. This thing called exit pupil, now I've tried to measure this. It's phenomenally difficult, because rather than put your eye close up to the eyepiece with a telescope, you sit about a foot away, you see the eyepiece, and in the centre of the eyepiece there is a bright circle. And then you have to try and measure the diameter of that. But of course, it's not like a piece of wire you can get hold of and run a gauge along. I tried to do it with a pair of vernier calipers and kind of gave up. It's very difficult to know when you've got the vernier caliper just touching the two edges of the circle. But that's what's called the exit pupil. And doing the maths with the entrance pupil gives you the magnification. Well, we know what the entrance pupil was. We know what the magnification that he was using, and as I say, you end up with this very small number. This thing here is a thing called a Berthinen's dynamometer. In the mid-19th century, a UK amateur astronomer came up with a gauge that he claimed you could use to measure the size of the exit pupil from a telescope. This came up on a internet auction site. It was a price far beyond what I would consider buying it at, but maybe one day I'll get one and try it, and find it doesn't really work either, but there we are. And so what she and Dobbins are suggesting is that shining a very small diameter light into the front of the eye is exactly what you do when you go and see your optician, and they use this thing called an ophthalmoscope. So they shine a light into your eye, and then they use a microscope to examine the retina of the eye. When I've had this done, if I look away, I get an after image. I can see all the blood vessels on the retina of the eye. So maybe this is what was happening to Lowell, certainly in the case of his Venus observations, where he was seeing a pattern of lines projected on what we know to be essentially a black disk. So maybe that's what was happening as well when he was looking at the planet Mars. But the idea of life on Mars apparently just wouldn't die. Very attractive idea. You know, you've got things like H.G. Wells's War of the Worlds. Very nice science fiction idea of Martians, and perhaps Martians coming towards the Earth. But apparently, this comes from a popular science magazine in America in the 1930s, where a chap wrote an article and he said, "Wow, humans aren't the only intelligent beings that can engineer water. Beavers do it as well. Why is there not the possibility of beavers on the surface of Mars altering the landscape and building the canals?" And it goes on for about a page and a half describing what Martian beavers would be like, bearing in mind the lower surface gravity and the thinner atmosphere, so they need to be physically bigger and have bigger eyes and so on and so on. I haven't really got much to say in summary, because I think I've covered the subject quite well. So at that point, I'll take any questions.
Okay, Bill, thank you very much. It was very entertaining talk. Lots to think about. I'm surprised that Lowell and his assistants produced very, very similar sketches if they were looking at the back of their eyes. And yeah.
But there was smoke in the zone. Oh.
Well, because they would have seen each other's work, and you know, maybe there's kind of auto suggestion going on there that if the boss can see something that, and then he tells you that the observations that you made, it kind of puts an idea in your head that, you know, that's what's there. One of the things that I used to do when I was looking at the sun would be to see if the largest sunspots were above naked eye visibility. And so you kind of have to try and ignore what people are telling you if you hear that somebody has seen it, you know. But you have to make the naked eye observation before you make the telescopic observation, because if you see the sunspots through the telescope, it gives you a clue as to where they are on the sun. So when you come to look at the naked eye, you kind of know where they are. That you actually need to do it the other way around, so you're not introducing bias to yourself. That you already know where they are, and then you can see them.
Just like observing faint objects with somebody else. So questions as usual, online people. Can you raise a digital hand? Those in the room, throw £10 notes in, and
Well,
Just to point out, going back to Lowell and his books, some time ago I saw an old newspaper on his books on the canals of Mars. He'd actually, like you were saying about Kirchhoff, he'd actually put arrows, and he was actually showing the direction of flow of the water. I recollected it. And it worked out quite a scheme. I can remember.
well, clearly, if he wanted to demonstrate that they were kind of artificial in origin, then they would need to work as a distribution, so it would be capable of analysis. Yeah.
It's something like that. I've got that, I would say this is from my memory of something I read about 4 or 5 years ago.
Which links back to what I was saying earlier, that there are periods when you can observe, and then there are periods when you can't observe, and then that's when you sit down and you think, well, you can have to explain all of this. And, yeah, you try and work out, or he thought he was working out all of these. Yeah.
Okay, right, yeah. Anybody else got any questions? Tony?
That the optical examination of the eye, that doesn't have scanner telescope 30 odd years ago about that.
Yeah.
Something remembers.
Yeah, it's been around quite a while, yeah.
Yeah.
But it wasn't around in Lowell's day, it's kind of, relatively recent, suggestion, shall we say. The thing is that, or perhaps another piece of evidence, is that Lowell died at the age of 61 from a brain hemorrhage. One of the risk factors for brain hemorrhage is high blood pressure. This is one of the things that you can discover through ophthalmic examination. So maybe the blood vessels in the back of his eye were bigger or distended, shall we say, compared to somebody of more normal health.
Mick Nichols online. Mick, can you unmute yourself? And can we have your
Yeah,
question?
but I can't see myself for some reason on the gallery.
Your video's switched off.
Yeah, but I can't see my name either, Paul.
You're not here, mate. Don't worry about it.
Mick, we've got you on the gallery. Don't worry.
Right, okay. I was just wondering, with the size of telescope they'd be using to observe Mars, is there any possibility that they could see Varys Marineris visually?
I don't know, short answer. Certainly the extremely large volcano, Mons Olympus Mons even, that was discovered before spacecraft. So, yeah, and I remember Patrick Moore saying, that when the first space photographs of the planet Mars were received on Earth, it was a distinct disappointment to see a cratered surface. They kind of holding on to a hope that there might be something there. I do personally get frustrated about the number of spacecraft that get sent to Mars. Mars is dead, there's no point in keep going back and looking for life, even if it's microbial life. To my mind, it's a sterile world, and we seem to send more spacecraft to Mars than probably any other planet.
It's the easiest one to do.
Well, yeah, that does help, yeah.
And a drone works.
Tony again?
So there's 2 of us in this room who've looked through the 24-inch observatory, haven't we? Yeah. And it wasn't stunning.
No.
So we're looking at Jupiter. So obviously it's an observing session of 1.
Yeah.
You don't know how good the sky is, the Flagstaff seeing, but I've seen better Jupiters.
Mind you, was paranoid about anybody touching it.
Yeah,
Obviously,
yeah.
a student or something, that was there at night. Yeah, it was poor.
It was, yeah. It
It
disappointing.
was the scene.
Yeah. Flagstaff seeing. John Leach has that,
Well, he's just taking a photograph from the bottom of his garden. Again.
So we did the tour at Flagstaff, and a couple of other guys as well. And they actually spoke more about Tombo's achievements, didn't they? And they spent much. If you went to see the astrograph that Tombo used in the blink comparator, and there was much more emphasis on that than Lowell's work, even though Lowell funded himself.
Yeah, because Lowell was so wedded to the canals that a lot of other astronomers clearly didn't believe existed. If you were a jobbing astronomer and you got a job at Flagstaff, it was kind of the end of your career, really, because you know you were working somewhere that wasn't a proper astronomical observatory. But you know, that's the going back in history. Orwell Park, there was an astronomer who was paid by the gentleman owner, and when these gentlemen's observers discovered things, it was quite often that the gentleman would claim they'd made the discovery. You pay the piper, you call the team gun.
How successful have you been at Orwell Park in observing Mars, or have you not tried?
That's funny you should ask that question. The telescope at Orwell Park was used like a lot of gentlemen's observatories. It all depended on the owner. So if the owner lost interest in astronomy, clearly he'd want to get rid of the telescope, and the gentleman astronomer would lose his position. In the case of Orwell Park, the owner died in 1889, and the people who inherited the building, the telescope, had no interest in astronomy. At one point, probably between the wars during the Great Depression, they came up with the idea of selling the telescope and knocking the building down. They had a few people around to sort of have a look, and the answer was, yes, you can knock the building down if you want, but it's been so well built, it would be a very difficult job, and it will cost you more to knock it down than you would get from selling the material you recovered. So the telescope then went through a period of unuse, shall we say. In the 1920s, there was a solicitor in Ipswich, a man called Edward Collinson. He was just starting his career in the legal profession, relatively short of money. And he went to see the family at Orwell Park and said, "Can I use the telescope?" And they said, "Well, we don't know what state it's in, but it's up there. If you want to go and use it, we're not." So he renovated the telescope after 30 odd years of unuse. And he used the telescope to observe the planet Mars. He was drawing the planet, and he was quite authoritative within the British Astronomical Association. Because he was a lawyer, effectively he was giving the BAA legal advice for no cost. And he used the telescope all in the late 20s down to the outbreak of the Second World War, so probably about 10 years. After the war, again, when the telescope wasn't used, the family said, "Do you want to come back and use it again?" And he said, "Well, it's had another 6 years of unuse, so I have to repair all that damage and before I start using it again." He was a bit better off now in financial terms, and so he got his own telescope and carried on observing Mars. So if you come to Suffolk and you ask about Collinson, everybody said, "Oh, it's fantastic Mars observer." But he had the same problem that Lowell had. You could see it for a couple of years, see it for sort of a month or so, and then you couldn't see it for a couple of years. And so I think his observing record more rests on what he was doing between Martian oppositions, which was variable star work. Even now, if you go on the BAA website, you can get his variable star observations, and there are literally thousands of them. And he died in 1990, I think. And some of his variable star observations are sort of 1985, 88, right, virtually up to a few weeks before he died, he was still doing variable star work.
Okay, thank you. Tony again?
So observing with the Nertz refraction, how does it compare with modern telescopes? Have you got a feel for that?
Well, I'll hold my hands up and say I'm not really kind of a telescopic observer. I'm probably not the best person to ask. It's not, as I said, not a particularly good lens. It is about 5 miles from Felixstowe Dock, the biggest container port in the country, which was also started by Colonel Tomlin. So it's, yes, it's not in the best position. It's an okay telescope. When we have visitors round, and if Saturn's in the sky and we put it at Saturn, they all go wow when they put their eye to the eyepiece, you know.
Is it a double sorry?
Yes, yeah. I forget the number now. There've been quasar observations undertaken with it. You know, we go down to about now 13.5.
3C273 then.
Mm.
Roy?
Just going back to Lowell, how much do you think he sort of influenced other scientists elsewhere? I mean, there's reports that Marconi and Tesla reported they were getting electrical signals, radio signals from Mars in sort of the 1910s and 1920s. And of course, you got then popular culture like H.G. Wells and those sort of stories all sort of started around about the turn of the century when Lowell was doing it. So how much did that sort of affect that the culture we have now of sort of Mars attacks and these sorts of things that's in culture today?
Well, certainly he was a champion to the cause, shall we say. You know, that he was out there saying that there are canals on Mars and there is, you know, life on Mars. So, you know, he was kind of putting the idea out there, and other people would run with it. Yeah.
I mean, even today, I mean, you get people saying there's pyramids there, and you know, the face of the mountains I've never seen fighting. You know, we're always looking for. We're looking for these sorts of things, no matter what we're talking about. I mean, you know, it's is it a need that we, you know, that we need to find alien life or intelligent life somewhere? Do you think?
Yeah, that's probably true. That, you know, if we definitively knew we were the only planet with life in the whole universe, that certainly for me that'd be quite frightening.
Yeah.
No, you are literally, you know, this is it kind of thing, and there's nothing more.
Lots.
So, you've spoken about a couple of observatories tonight. I'm taking an educated guess here, but what would you recommend the second most interesting observatory to go visit, assuming that the J.A. Jones Hoover Observatory is actually number one in this case? Okay, so what would be your second recommendation?
That's a really difficult question.
One plane ticket to go anywhere. Where are we going?
I was having a conversation with somebody when I was doing a similar talk a few weeks ago, and he said, "Oh yes," he said, "I'm like you. I like visiting observatories." And he said, "But my wife can't see the point of it." She says, "Well, they're all the same." No, there's no two observatories anywhere in the world are ever the same. They've all got something unique about them. I think I'd have to come for an observatory I haven't been to, the Pope's Observatory.
Which one?
Castel Gandolfo.
Oh, really difficult to get into.
Even if you're a left footer.
Definitely if you're a left footer.
The other one would be Kodia Canal in India. So I'm currently Deputy Director of the BAA Historical Section. The section was founded in 1930 with Mary Evershed as our first director. And of course, Mary and John Evershed ran Kodia Canal Observatory for many, many years before they retired and came back to the UK. Again, that's one that's supposed to be quite hard to visit because it's very remote.
They're interesting choices you've done there, because you took it maybe from a historical perspective,
Yeah.
whereas myself being more of a telescope geek, I'd had the VLT as number one. In fact, I think myself and some other guys have been there.
Yeah.
That's kind of mind-blowing, that place, but for different reasons. That's technology writ large,
Yes.
and it's difficult to get to. Expensive.
Any more questions? No. Ladies and gentlemen, will you join me in thanking Bill Barton, giving him a big Experience to International Society. Thank you for an absolutely wonderful talk. Thank you very much, Bill.